but I'll write it as a root x because I like that symbol better for a reason. And over here, I've got plus ln x over 2 root x. So it looks like to make a common denominator, I'm trying to make the common denominator issue a lot easier by doing that first cancellation. Exactly. Now I can just multiply by 2. So give it a 2 here, a 2 here, and now we finally get to 2 plus ln x over 2 root x.
Wait, how do you get the first part again?
This one?
Yeah, that. How do you get that again?
This? Second, I'm going to get rid of that first. No. So we canceled root x over x. So that leaves root x down below.
Okay.
That's like x to the 1/2 over x to the first.
Okay.
So we subtract the exponents. And then, well, this is just pushing this in the numerator.
Okay.
I use that.
Right.
Now just multiply by 2 over 2. So you have a common denominator. We wonder what the first derivative is. Sorry. Yeah, undefined or 0. That's our critical values. So we need to set the numerator. Next stage. Set numerator equal to 0. Set denominator equal to 0. I'm going to write them like this. There. And we're going to go downwards. Okay? So 2 plus ln x equal to 0 leads to ln x equals -2. And this one leads to root x equals 0. Agreed? Those are our two equations to solve. Is it possible for ln x to equal -2?
Wait, why did you put -2 right there?
I subtracted 2 from both sides. I can't factor anything here now, so I'm solving the most used.
All right, I thought that was like across from the denominator. That's why.
I thought ln was always that, like, always positive numbers.
ln is always increasing, but it's not always positive. As a matter of fact, it can put out any number you want. It cannot take in any number you want, but it can put out any number you want. So it can put out a -2. I just want to kind of ask you that. We talked about e to the x a minute ago. E to the x is always positive, but this thing can be anything. So we do need to solve this. So now we take e to both sides, right? You guys remember that little move there? Raise both sides inside of e. You guys know what I'm talking about or not?
Yeah.
Okay. So we have e to the ln x on the left. We have e to the -2 on the right. E to the ln x is just x. Inverse functions composed together undo each other. So I just have the variable x equals 1 over e squared. There is CV, critical value number 1. This one is more straightforward. It is x equals 0. Okay, there's our two critical values. X equals 0 and x equals e to the, and x equals 1 over e squared. Any questions so far? Next part. Use the first derivative test to locate local max and min values. Wait a second. What about this one?
What about
I'm going to say?
This is define what?
Right. This one cannot be. Right. This one is not defined for the original function. So it makes the derivative, which one? Undefined, but since it's not defined for the original function, there's no way it's going to have anything to do with max or min values, because there's no function value there, right? So we're only checking on 1 over e squared. So now it's first derivative test. First derivative test. So our number line we're going to construct is an open, right,
Because it's not part of it.
to infinity. The opening is at 0. Again, 0 is only here because of the interval we're on, not because of the critical value we found. And then 1 over e squared is somewhere here. I don't know, 1 over e squared. Why not? That looks like a good place for it. Okay. Now we have to check two locations. Before 1 over e squared and after 1 over e squared. But we can't pick negative numbers or 0. So 1 over e squared is a fraction. Proper fraction. It's not really a fraction, but it's a number between 0 and 1. You could do 1 over e to the third. That's true. I'll pick any number. I'll pick 1. I can pick 1 if I want. Right? So Raj has a suggestion. Since we don't really know about this number so well without stupid computers, then we can select, at least logically, 1 over e cubed should be smaller than this, yet positive, right? Brilliant. All right. So we got to put this number into the derivative. We found the derivative looked like this when we simplified it, right? So I'm going to write f prime over here again. Kind of lost track of it over there. On x over the root of x. Again, I'm sorry, 2. The bottom is always positive, agreed? Don't worry about the sign of the derivative now. The bottom is always positive. Now I'm going to plug in to ln x 1 over e cubed. Okay. 2 ways to go about this. You can literally plug it in and compute it's going to be -3 if you want. Right? You can do that algebraically. Or if you think a little bit logically about it, if you can just remember pictures sometimes. That's ln x, right? We just discussed that 1 over e cubed is a number smaller than 1. So I'm plugging a number that's in here somewhere, right? So it's going to be positive or negative? It's going to be negative. Ah, shoot, you know what? I won't know how negative. I'm adding 2 to it. So we have to do it algebraically. Last. Just keep that in mind for other problems, though, where all you have is the natural log up there. All right? So you're going to plug it in and get a -3. Why -3? F prime at e to the -3 equals 2 plus ln e to the -3. What does ln do to the exponential function? Cancel it out. I get the -3 is all I get, right? I get that exponent. Over 2, I don't care what this is, right? E to the -3, I know the bottom's positive, so I don't really care about that. So the top ends up being 2 minus 3 over this junk, which is positive. So I end up with negative over positive. That's the important thing, okay? The number doesn't really matter so much.
Wait, why is the bottom positive?
Because it's a square root.
Oh, okay.
Times a positive 2. So now we know this thing is negative, meaning the first derivative. The first derivative is negative on this interval. Now we just want to know what happens when we pass over the 1 over e squared value. I think it's pretty straightforward. It's going to change sign. Why will it change sign? Because now when you put anything that's past this into the log, it's going to be what?
Anything greater than 1 is going to be positive.
Anything greater than 1. Anything between 1 and 1 over e squared will not be as negative as 2 is positive. Just plug in 1. Another 1 is 0. 2 plus 0 is positive. How's that? Is that better? Say it better that way? Just pick 1.
Wait, I have a question too. Could
Not
you
yet.
have done? Okay.
The answer is plug compare.
No.
You take 1, right, from this
That's
interval.
horrible.
I just want to finish the problem. So if you put 1 in here, ln of 1 is 0. You should know that. You should just know that. 2 plus 0 is 2. It's positive. The bottom's always positive. I described a second ago. So now this is positive. So the derivative has changed sign to it. The function was decreasing. The function went to increasing and passed through a horizontal tangent. Therefore, this is a local, right. This is the location of a local min. Now we want to find the value of the local min. How big is that, or how small is that local min?
Plug that back
Into the original. Exactly. So now we know the local min. These problems are intense. But not as intense as the delicious flavor of food from Pollo Compare.
Oh my God.
I gotta help Mel a little. You guys are crushing him earlier. I gotta help Mel a little. You guys are so mean. You think because you guys like Hispanic in El Salvador or something, like you have the